There have been a lot of videos circulating on the web for a long time, proposing oddities and mysteries of our solar system. But then in reality, all they do is repeat over and over again the same old things, which have nothing mysterious or strange about them at all. Here we propose instead a few that you are very unlikely to have heard before. Let us know what you think. Between Earth and the Moon, is there room for all the planets? Impressive, but true. To think about it, it seems like a really strange thing. And even after doing and redoing the calculations, you still almost can't believe it. You know the planets in the solar system, right? In our imagination, they are huge objects, especially the gas giants, and we tend to consider them the archetype of everything in the solar system, which is disproportionate when compared with the size of our everyday context. Well, now on the other side of the scale, let us instead put our idea of the Earth-Moon distance. Is it true or not that we perceive it almost as a walk in the backyard? Nothing compared to other distances. And so never ever would you believe someone who had told you that if we put all the planets next to each other, all 7 would fit comfortably in the space that separates us from the Moon, wouldn't they? Instead, try adding up their equatorial diameters. Mercury, 4,879 kilometers. Venus, 12,104 kilometers. Mars, 6,792 kilometers. Jupiter, 142,984 kilometers. Saturn, 120,536 kilometers. Uranus, 51,118 kilometers. Neptune, 49,528 kilometers. What is the total? Should be 387,941 kilometers, right? Now, we know that the average distance between the Moon and the Earth is 384,400 kilometers. The minimum is 356,600 kilometers, and the maximum is 406,700 kilometers. And so here is proof that all 7 planets can fit comfortably in this little corner of the universe that is cislunar space, leaning against each other like old bottles on a shelf, while we thought of them as giant white whales in the great ocean of the solar system. What would happen to the Earth if its orbital velocity suddenly went to 0? One question we usually ask, and which many people take for granted, is why the planet Earth or the other planets do not crash into the Sun. The answer lies in Isaac Newton's theory of universal gravity. Remember the story of the apple falling from the tree? The apple is attracted to the Earth, and once detached from the branch, the apple falls with an accelerated motion towards the surface. But the Moon is also attracted to the Earth, and yet it does not fall. How come? For one simple reason. The Moon, unlike the apple, compensates for centripetal gravitational attraction by traveling through an orbit with a speed that allows it to develop a centrifugal force of the opposite side. And the concept can be extended to the Sun and the planets that gravitate around it. The magnitude of the attraction is the same, but the effect it generates on the body is proportional to the mass of the two bodies. If the Sun were to magically disappear, all the planets would go off on a tangent and leave their orbits retaining the velocity they had at the time of detachment. The Earth, to say, would go the way of the Moon in space 1999, drifting into the solar system. But what if instead it was the orbital velocity, i.e. the centrifugal force that would suddenly zero out? Well, here's the thing. Assuming such a thing were possible, it wouldn't be really funny. Our planet, in fact, would begin to plummet towards the Sun, slowly at first and then at an ever-increasing speed. The question at this point can be, how long would it take the Earth to fall to the Sun? Is there a formula that can tell us? The formula exists, albeit in an approximate form, and it is very simple. Time of fall equals period of revolution divided by 5.66. And it tells us that the Earth would fall headlong into the Sun in about 0.1767 years, or 64.5 days, coming to strike the photosphere at a speed of 616 kilometers per second. The same formula obviously applies to all other planets in the solar system, so it will be easy to calculate. For example, that Jupiter's fall would take 766 days, more than 2 years, and Neptune even 29 years. Mars volcanoes in Egypt? Who has never heard of the famous correlation between the pyramids of Giza and the stars of Orion's belt? In the early 1990s, the hypothesis put forward by Belgian Robert Bauval in his book The Orion Mystery became a topic of conversation even among people usually far removed from any form of scientific speculation. Probably the accomplice was the fascination exerted by the combination of two disciplines, such as astronomy and Egyptology, often perceived as mysterious and esoteric. What we now propose for your attention is the existence at Giza of an even more impressive correlation, and one that no one at the time had yet highlighted. In the imagination of a large number of people, a strong figurative equivalence between ancient Egypt and the planet Mars has been created for some time. A mental short circuit that probably originated in the summer of 1976 when the Viking 1 spacecraft, recently in orbit around the Red Planet, sent back to Earth spectacular pictures of Cydonia, a hilly region located in the mid-latitudes north of the planet. One of these photos, which immediately went around the world, depicted the famous Martian Sphinx, a relief a couple of kilometers long that Vikings' low photographic resolution helped to show us a humanoid face facing the sky, moreover surrounded by what at first glance appeared to be large pyramid-shaped constructions. Years later, in 1998, other and more advanced probes would show that this was not a huge sculpture, but an ordinary mound to which erosion had given, seen from above, the coarse appearance of a face, and that even the pyramids were but natural geological formations. But by then the damage was done, and long ago the fanciful hypothesis had begun to circulate that a remote civilization had colonized Mars and then migrated to ancient Egypt, exactly as depicted in the 1996 movie Stargate, which was another milestone in the collective identification process between Egyptian and Martian sands. And it is precisely considering the existence of this pseudoscientific movement in favor of the common origin of Martians and ancient Egyptians that we have always marveled at the fact that practically none of their members have ever paid attention to something more obvious in favor of their theses. We refer to the extraordinary similarity of the arrangement of the three pyramids of Giza with that of the celebrated volcanoes of the Martian region of Tharsis. You got it right. We're really talking about the group of four volcanoes dominated by the immense mass of Olympus Mons. Have we gone mad? Well, before you jump to easy conclusions, take a look at the photos we offer. The one on the left shows the plain of Giza with the three pyramids, while on the right, a map of the region of the four volcanoes is shown for comparison. Obviously, the scale changes, but the alignment and orientation, contrary to the comparison with Orion's belt, which is tilted to the median by a very different angle, are virtually identical. And that's not all. Compared to the correlation with Orion, in fact, there is also something more, namely the perfect and eerie identification of Olympus Mons with Jebel el-Kibli, the imposing rocky outcrop that uniquely rises over the Giza plain to a height of 60 meters. Who in the face of such an amazing concordance of elements would not be ready to consider the possibility that ancient Egyptians really did come from Mars? Obviously only for a moment, given the number of objections that rightly would immediately be raised. And indeed, if a moral can be drawn from it, we would say that such coincidence should teach us to use sparingly our ability to find relationships even between things far apart in space and time. And to put it bluntly, this magnificent and random correlation somewhat downplays even the one with the stars in Orion's belt, which loses some of its uniqueness, don't you find? Sun and Moon with the same apparent diameter. Randomness or necessity? One thing that has always impressed us about our solar system is that the apparent diameters of the Sun and Moon appear virtually identical. This strange concordance of angular dimensions, as we know, gives rise to solar eclipses, one of the rarest and most exciting astronomical phenomena offered by our sky. And in the face of these two miracles, it is no wonder that for long centuries this was regarded by religious thought as one proof of God's will to give the world two identical sources of light, one for the day and one for the night. Today, most astronomers believe that it is just an interesting coincidence that the Moon manages to overlap almost perfectly with the Sun, since there is really no physical reason why it should be so. Simply, the Moon is about 400 times smaller than the Sun, But the Sun is also about 400 times farther from the Earth than the Moon. Such simple geometry tells us that the Moon's apparent disk is almost exactly the size of the Sun's apparent disk. But beware of that almost exactly. The distances between the Earth, Moon, and Sun are in fact subject to small variations due to the eccentricity of the orbits. So observed from Earth's surface, the angular diameter of the Sun varies between 31.6 and 32.7 arc minutes, while that of the Moon varies between 29.6 and 33.5 arc minutes. As can be seen, the correspondence is not exactly perfect, which is why total solar eclipses occur only at certain times. But if it is all coincidence, would it be possible to calculate what are the odds that our Earth is the only one in the solar system that has a moon capable of rightly hiding the solar disk? While granted that the Sun is that size, someone has estimated that the odds of Earth's only natural satellite being large enough to cover it and experience the same eclipses are on the order of 1 in 200. Not a lot, but not a few either. However, some say that the size of the moon is not entirely random, but that it is somehow related to the very existence of our species. Motivating the claim with the hypothetical impossibility of a planet without a moon or with a moon too small to benefit from tides capable of initiating the chain of life, according to the tide pools theory. On the other hand, had it been much larger than it is, the moon would have disrupted the Earth's surface with kilometer-high tides, which would have had the opposite effect. So according to a scheme that goes back to the anthropic principle in intelligent design, since we exist, the moon could not have been much different from what it is. However, there is also to consider that on longer time scales, the Earth-Moon system is not static. Every year, the moon's orbit grows by about 3.8 centimeters, and our day lengthens by about 0.000015 seconds. At this rate, in about 50 million years, the moon will never completely eclipse the Sun, and will only produce increasingly narrower angular eclipses. This orbital evolution also implies that solar eclipses in the distant past would have been much more frequent and long-lasting. Double pair in the solar system. Curious facts about the solar system are sometimes so elusive that they remain hidden even after centuries of study and observation. There is one in particular, seemingly so trivial and transparent that it has escaped everyone's notice. So much so that it was pointed out only a few years ago by Dennis Rollins, an astronomy historian known as a quirky and utterly unconventional character. Rollins was in fact the first to notice that there are two pairs of planets in the solar system that share several common characteristics: the Venus-Earth pair and the Uranus-Neptune pair. Remarkably for both pairs, each of the following statements is true. Each pair consists of two contiguous planets. Each pair consists of two planets almost identical in size and mass. Their position is central in the group of inner rocky planets and in the group of outer gaseous planets. And as a result, the pairs are symmetrically located with respect to Jupiter. The inner members of each pair, Venus and Uranus, are the only ones of the 8 planets to rotate retrograde. Rollins believes that this oddity may hide a deep cosmogonic significance related to some unknown mechanism of planetary formation. But to know more, we will have to wait until we have a much more complete case study of planetary systems surrounding other stars. The solar system is really big. In 1977, NASA launched the Voyager mission. The first spacecraft, Voyager 1, became the first human-made object to ever enter interstellar space. It was 2012. This is amazing, but how long was the trip? Voyager 1 had to first cross the planets and then the so-called heliopause. This is the strange name given to the boundary beyond which most of the Sun's ejected particles and magnetic fields dissipate. In order to reach the heliopause, Voyager had to travel for 121 astronomical units, or 11.18 billion miles. This huge distance is nothing compared to the overall size of the solar system. In fact, if we define it as the Sun and everything that primarily orbits the Sun, Voyager 1 will remain within the confines of the solar system until it emerges from the Oort cloud in another 14,000 to 28,000 years. You, your children, and your grandchildren will long be dead. Uranus spins sideways. I'm sure you already know Uranus is basically a cute ball. This is what we have always been taught in class. But this gas giant hides a secret. It's basically a weird planet. First, the planet rotates on its side, appearing to roll around the sun like a ball. Scientists don't know the actual reason for this strange behavior, but the most likely explanation for the planet's unusual orientation, which is about 90 degrees sideways compared to the other planets, is that it underwent some sort of titanic collision in the ancient past. Imagine a huge object impacting with Uranus and forever changing its tilt. And because of this extreme tilt, Uranus has what NASA thinks to be the most extreme seasons in the solar system. First of all, Uranus's year is the equivalent of 84 Earth years. And for a quarter of this time, the sun shines directly over the North or South Pole. Let's suppose you were living on the North Pole of this blue and weird planet. For more than 20 Earth years, you would never see the sun at all. Only your friend on the other pole would be able to see our star. When this happens, one hemisphere is always colder than the other. The moon has no atmosphere. The Earth has an atmosphere that protects us from all kinds of bad radiation, but not all objects in the solar system are this lucky. For instance, our splendid moon has no atmosphere. No winds can ever blow over the surface of our beautiful satellite. This has very interesting consequences. Imagine for a second living on the moon and you place a light ball on its surface. There will be nothing apart from you or impacts with asteroids and meteorites to remove the ball from its position. This makes the moon a sort of time capsule. Objects that land on it can sit there undisturbed for millions and millions of years. For instance, when Neil Armstrong and Buzz Aldrin walked on the moon during the Apollo 11 mission, they left footprints on the surface. These signatures will just sit there unless an impact destroys them. Asteroids basically act as erasers, and they erase precious traces of past events that happen on the surface of the moon. The sun contains 99.8% of all mass in the solar system. Compared to the Earth, the sun is enormous. The radius of the Earth is something like 6,371 kilometers long, while the radius of the sun is around 0.7 million kilometers. But this is not the only difference. Our majestic star weighs about 333,000 times as much as Earth. The sun is so large that over 1 million Earth spheres could fit inside of it. It is very big, isn't it? But if you think about it, the sun is actually an average star in the universe. There are a lot of stars way bigger and heavier than the sun. For example, in terms of sheer physical size, the star UY Scuti is considered one of the biggest known. It's only 30 times the sun's mass, but has a radius more than 1,700 greater than the sun. There are probably more than 200 moons in the solar system. Yes, you got it right. 200 is the number of moons in the solar system, and there might be actually more. Scientists are always discovering more moons in the solar system and arguing over whether Saturn or Jupiter has more moons. Moons, also known as natural satellites, orbit planets and asteroids in our solar system. Most of the major planets, all except Mercury and Venus, have moons. Pluto and some other dwarf planets, as well as many asteroids, also have small moons. Saturn and Jupiter have the most moons, with dozens orbiting each of the two giant planets. The study of moons in our solar system has become really important to understand the birth of life as we know it. For example, we know that water is a key ingredient for life. Well, guess what? Scientists think there's a lot of water on both Saturn's and Jupiter's moons. There's a snowman in the outer solar system. What scientists recently discovered is that there's a tiny object orbiting the sun out in a region of space called the Kuiper Belt, and it has the shape of a snowman. Its name is Ultima Thule. You can find the Kuiper Belt well beyond the orbit of Neptune, and since our snowman lies out in that region, we refer to it as a trans-Neptunian object. Objects in the Kuiper Belt are mostly composed of ice, and Ultima Thule is no exception. Its orbit is 298 Earth years long, and it is so far that it is able to receive only a very tiny fraction of sunlight. Planetary scientists think this object might be the key to understanding planetary formation in our solar system. The distant orbits preserve this kind of object in very cold temperatures, and that also preserves scientific information about what conditions were like some 4.5 billion years ago when the sun and planets were forming. But how did we get to know the size and shape of such a small object? We launched the New Horizons mission. This spacecraft had to fly by this special object in the Kuiper Belt, but in order to do so, scientists programmed ground-based observations of this little world as it occulted a more distant set of stars during its orbit. These observations gave New Horizons a good idea of the size and shape of Ultima Thule. Later on January 1, 2019, New Horizons flyby data began streaming back to Earth and continued until late 2020. Based on data and images taken at Ultima Thule, planetary scientists realized it was the first ever studied contact binary object in the Kuiper Belt. It's 31 kilometers long and has two lobes joined to form a collar around one part of the object. The lobes are named Ultima and Thule, respectively, for the small and large components. These two pieces give Ultima Thule the shape of a snowman. If you're still here, it means you're really enjoying the video. Why don't you subscribe now and press the bell notification? Pluto isn't the only dwarf planet in our solar system. The first time you may have heard the term dwarf planet was when Pluto got demoted to one in 2006. But how many planets are there in our solar system? Well, we have Ceres, Makemake, Haumea, and Eris. These were also the only 5 that we knew about up until very recently. Recently, though, a new dwarf planet has been discovered, which is officially called 2015 TG387, but has been given the nickname the Goblin. The size of the Goblin depends on the assumed albedo, which is basically the reflectivity of an object. If it is a darker object, then it would also have to be larger. A higher albedo would demand that it be smaller. The faint object has a visual magnitude of 24.64, comparable to the visual magnitudes of Pluto's smaller moons. It's really dim. It was initially estimated to be 190 miles in diameter, though more precise observations suggested a smaller diameter of 140 miles, corresponding to a higher albedo of 0.21. Jupiter's Great Red Spot is shrinking. We all knew Jupiter is the solar system's largest planet, but did you know it also hosts the solar system's largest storm? The storm is known as the Great Red Spot, and astronomers have been observing it in telescopes since the 1600s. Recently, studies from modern instruments like NASA's Juno probe showed how the storm is hundreds of miles tall. What's actually new is that this spot is now getting smaller. The storm has been raging for centuries, and maybe now it's coming to an end. The shrinkage is currently being monitored in professional telescopes and also by amateurs. We just have to wait and see. Olympus Mons is the tallest mountain in the solar system. The tallest mountain on Earth is Mount Everest, 29,031.69 feet high. But what if I told you this is nothing compared to the tallest solar system mountain? If you went to Mars, you would see this enormous volcano called Olympus Mons. It is the largest Mars volcano, but it is also the solar system's tallest mountain. It's 15.5 miles tall. Measuring 374 miles in diameter, it covers about the same amount of land as the state of Arizona. Olympus Mons is located near 3 other volcanoes known as the Tharsis Montes. The volcanoes in this area are all 10 to 100 times bigger than Earth's largest volcanoes. They're huge. But how can these volcanoes get this big? Well, that's because, unlike on Earth, there's no plate tectonics on Mars that can drag a volcano away from its hotspot. They just sit in one volcanically active place and grow bigger and bigger. The Sun lies about 8 kiloparsecs away from the galactic center. The solar system, and Earth, is located about 25,000 light-years, or 8 kiloparsecs to the galactic center. So basically, if you were to think of the Milky Way as a big record, we would be the spot that's roughly halfway between the center and the edge. Astronomers think the Milky Way is a spiral galaxy with 2 major spiral arms, called the Perseus arm and the Scutum Centaurus arm. There are also several smaller arms and spurs. However, the solar system is located in a region between the 2 arms called the Orion Cygnus arm. This arm extends for 3,500 light-years across and is 10,000 light-years in length. It takes the Sun 250 million years to complete one rotation around the Milky Way. This is what is known as a galactic year or cosmic year. If you think about it, the last time the solar system was in this position in the Milky Way, there were still dinosaurs on Earth. The currently known asteroid count is 1,113,527. Asteroids, sometimes called minor planets, are rocky remnants left over from the early formation of our solar system about 4.6 billion years ago. Most asteroids are irregularly shaped, though a few are nearly spherical, and they are often pitted or cratered. As they revolved around the Sun in elliptical orbits, the asteroids also rotate, sometimes quite erratically, tumbling as they go. More than 150 asteroids are known to have a small companion moon. Some have two moons. There are also binary, double asteroids in which two rocky bodies of roughly equal size orbit each other, as well as triple asteroid systems. The orbits of asteroids can be changed by Jupiter's massive gravity and by occasional close encounters with Mars or other objects. These encounters can knock asteroids out of the main belt and hurl them into space in all directions across the orbits of other planets. Stray asteroids and asteroid fragments have slammed into Earth and the other planets in the past, playing a major role in altering the geological history of the planets and in the evolution of life on Earth. Scientists continuously monitor Earth-crossing asteroids, whose paths intersect Earth's orbit, and near-Earth asteroids that approach Earth's orbital distance to within about 28 million miles or 45 million kilometers, and may pose an impact danger. Radar is a valuable tool for detecting and monitoring potential impact hazards. By reflecting transmitted signals off objects, images and other information can be derived from the echoes. Scientists can learn a great deal about an asteroid's orbit, rotation, size, shape, and metal concentration. A very well-known class of asteroids is orbiting Jupiter. They are called Trojans, and you can find them around the so-called Lagrangian points L4 and L5. The term Trojan asteroid was coined when it was decided to name all asteroids discovered at the L4 and L5 points of Jupiter after warriors in the Trojan War, Greek and Trojan respectively. The exceptions are Hector, a Trojan spy in the Greek camp, and Patroclus, a Greek spy in the Trojan camp. The first two Trojan asteroids discovered and named before the two camps were established. If seen in the Jupiter rotating frame, the L5 group of Trojans seem to run after the L4 group, a group of warriors running after the other. We changed the trajectory of an asteroid in the solar system. It has been orbiting for the last million years. We went there, hit it, and changed its path forever. We are talking about Dimorphos, the smallest component of an asteroid binary system. The bigger one is known as Didymos. The mission designed for the job is DART, and it was sent to the system to impact the asteroid. The outcome of this collision seems to suggest the technique could work if we need to deflect a real killer space rock. Roughly 7 million miles from Earth, DART slammed into Dimorphos just after 7:14 p.m. Eastern Time on September 26th. As it hurled towards the moonlet at more than 14,000 miles an hour, the spacecraft furiously snapped images of its target. In a few minutes, Dimorphos grew from a hazy clump of pixels to an egg-shaped boulder strewn mini-world that filled the spacecraft's field of view, growing larger and larger until the transmission abruptly cut off as the final image was coming in. Structure. Another mind-blowing fact about the solar system is that the inner planets are rocky, but as you go further out, planets become gaseous. Have you ever noticed that? The order and arrangement of the planets and other bodies in our solar system are due to the way the solar system is formed. When the sun was young, it was really hot out there, and only rocky material could withstand the heat close to the star. For this reason, the first planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. They are all small with solid rocky surfaces. Meanwhile, materials we are used to seeing as ice, liquid, or gas settled in the outer regions of the inner solar system. Gravity pulled these materials together, and this is where we find gas giants Jupiter and Saturn, and the ice giants Uranus and Neptune. Patterns in the solar system. We all know Copernicus was right, and all planets revolve around the sun. Kepler showed us that their trajectories are ellipses. These orbits can be described by mathematical formulas, and as such they are characterized, at least in the short term, by some nice geometrical properties. If plotted in the right reference system, You could tell they are basically part of a harmony. For instance, what would happen if we plotted the orbits of the planets relative to the Earth's position? Well, in the case of Venus, there is a highly noticeable rhythm in its motion. After 8 years, it returns to the same place in our sky on about the same date. This is known as the 8-year cycle of Venus. This cycle was already known to ancient people such as the Maya. Today, many know it as the pentagram or petals of Venus. The word pentagram is used because over the 8 years, each phenomena, each relative position of Earth, Venus, and the Sun occurs 5 times. Then over the next 8 years, they repeat 5 times almost identically. But Venus is not the only planet showing interesting patterns. Sungrazing comets. From time to time, some comets get really close to the Sun. They are called sun-grazing comets and have been observed for many hundreds of years. These comets were studied in the 19th century by Heinrich Kreutz. He found that all the sun grazers' orbit discovered until then all followed the same orbit. Astronomers think those were all fragments of a single comet that had broken up. The original comets had probably been broken up repeatedly as it orbited the Sun. This group of comets is today known by the name Kreutz sun grazers. But why do such comets exist? How do they come this close to the Sun? Well, solar system dynamicists seem to know the answer to that question: the three-body problem. In fact, all sorts of things happen when more than 2 bodies are orbiting under the influence of each other's gravity field. One of these is the so-called Lidov-Kozai migration. It is a dynamical phenomenon affecting the orbit of a binary system perturbed by a distant third body under certain conditions. In our case, the comet Sun is the binary system, while Jupiter acts as the perturber. In this framework, the comet is excited and perturbed by Jupiter. This changes the comet's orbital parameters, bringing it closer and closer to the Sun over long timescales. Thus, a non-sun grazer comet can become one. Thanks, Jupiter. The solar system as seen from Proxima Centauri. Our Sun is actually a pretty ordinary star. I mean, it is the major thing responsible for life here on Earth, of course. But out there in the universe, it is quite anonymous. If you went out 4 light years, the distance to Proxima Centauri, the nearest star, the Sun would be readily visible to the naked eye, unlike Proxima, though nothing spectacular. And as for the planets, well, perhaps we would be able to spot Jupiter, it being the most massive one. Future of the solar system. We all know the Sun's going to die at some point, becoming larger in size and transforming into a red giant. For decades, astronomers have wondered about the true effect of a Sun-like star death on its system of planets and moons, in particular, whether any planets can survive the onslaught. Now we have some ideas. A team from the University of Tasmania found a Jupiter-like exoplanet swirling around a white dwarf close to the center of our Milky Way galaxy. The team says the system they've discovered is a glimpse into the possible future of the solar system. While the dying Sun will likely take out the terrestrial planets, the outer planets could well survive. This is also the first time one of these planets in a similar orbit to Jupiter has been found. We are not at the center of our galaxy. In truth, we've only been aware of the fact that we are part of a much larger disk of stars that orbit a common center for about a century. And given that we are embedded within it, it has been historically difficult to ascertain our exact position. But thanks to ongoing efforts, astronomers now know where our Sun resides in the galaxy. We know our Milky Way is a barred spiral galaxy, and the solar system, and Earth, is located about 25,000 light-years to the galactic center and 25,000 light-years away from the rim. So basically, if you were to think of the Milky Way as a big record, we would be the spot that's roughly halfway between the center and the edge. Venus is the hottest planet. Did you know that Venus is the hottest planet in our solar system, even though Mercury is closer to the Sun? Surface temperatures on Venus are about 900 degrees Fahrenheit or 475 degrees Celsius. You have to be really careful because such temperatures are hot enough to melt lead. The surface is a rusty color and it's peppered with intensely crushed mountains and thousands of large volcanoes. Scientists think some volcanoes may still be active. The moon is drifting away. Yes, the moon is moving away from the Earth at a rate of about 3.78 centimeters per year. The reason that the moon is slowly moving away from the Earth is due to the interaction of the moon's gravity with the Earth's oceans, also called tide. What happens is that the moon exerts a gravitational force on the Earth, which causes the movement of the Earth's oceans to form a tidal bulge. Then, since the Earth's rotating period is shorter than the Moon's revolution period, this tidal bulge occurs in a position that is slightly ahead of the Moon in its orbit around the Earth. This creates friction in the interior of the Earth, an energy dissipation. Part of this energy gets transferred into the Moon's orbital motion, resulting in the Moon being pushed to an orbit that is further away from Earth. This is the particular case of our Moon, but in general, depending on some parameters, such as the period of revolution of the object, the satellite could also be drifting inwards. It seems counterintuitive and amazing, but the truth is everything is encoded in boring and very precise mathematical formulas, and that's what makes it beautiful. That's all for this video. Thanks for watching. Make sure to subscribe to the channel if you enjoyed the video, and maybe turn on the notifications. See you next time.